Thanks, Brett. So, guys, we've just pre-recorded this session this morning because Justin, my co-presenter, is based in Colorado and wasn't able to attend in person this morning. I'm going to be on the live chat, so if there's any questions at all, please put questions into the chat. I'll just press play here, and if there's any questions at all, please feel free to ask anything. If we don't have an answer for you, leave your email address, and we can follow up afterwards with a direct email. So you can send a direct message there as well.
Hi everyone, my name is Justin Baston and I'm going to be joined with my colleague Paul Martin. Today we're going to discuss managing and monitoring mainframe environments with modern tools, specifically Unisphere for PowerMax, Dell's Cloud IQ, and a REST API that was specifically developed for PowerMax customers. Let's jump in. So, my name is Justin Baston, as I said. I'm an engineering technologist here at Dell Technologies. I've been here since 2012, but I'm a seeker of knowledge and understanding, and I work on storage solutions really to achieve what the customer wants to achieve, what their outcomes are. So for today's session, we're going to look at a Unisphere timeline, and then I'm going to jump into Unisphere and Cloud IQ to talk about performance monitoring and how you can administer the PowerMax from the Unisphere environment. At the end of my section, I'm actually going to send it over to Paul Martin, my colleague, who's going to dive deeper into the REST API and how you can leverage it with your PowerMax environment to administer and to monitor those environments. So let's jump in. As a mainframe customer, I was a customer for about 8.5 years. We would never put anything new on our mainframe as it housed our most critical applications. If those applications died or an abend were to occur within those applications, it could possibly significantly negatively impact our business. So this is to show you kind of how long Unisphere has been around. All the way on the left-hand side, Unisphere first came out publicly around October 2012. But the components of Unisphere, which was actually an administration tool and a performance tool, were developed around the 2008 time period. But yeah, at the time, EMC did not release those products out to the general public. We use those tools for our purposes, to troubleshoot the box, to monitor environments out there, at the time EMC storage arrays. And we got the idea around that 2012 to package it together, which is what we called Unisphere, and release it to the public. Now, around the November 2014 timeframe, you see right almost in the middle of the chart, it goes from a versioning of Unisphere 1.6 to Unisphere 8.0. Now, you didn't miss Unisphere 2, Unisphere 3, Unisphere 4. The company at the time did a rebranding of most of its software products from whatever version it was at to Unisphere 8.0. So don't be alarmed that you're missing 2.2, 3, 4, 5, and 6. And then Unisphere for mainframe customers really started to be leveraged by them around the 2018 time period on the right-hand side. The primary reason is prior to Unisphere 9.0, it was Java. And in Unisphere 9.0, we came out with HTML5. It provided a faster, more user-friendly interface for all of our customers that leveraged Unisphere. And then in July 2022, on the far right-hand side, Unisphere 10.0 was released. And there were significant features and functionality in Unisphere 10.0 and Unisphere 10.1 that came out in October 2023. So you can see from this slide that the product itself has been around publicly since 2012, but it's been in existence since 2008. So rest assured, you're not putting your mainframe data at risk by leveraging this tool. Now, one of the major features, this is the Unisphere 10.0 mainframe dashboard, which is under the host. And I'm showing this here because as customers started using it, one thing that customers wanted was more of a one-stop shop for their mainframe, for our mainframe customers. So what we did is we removed a lot of the white space and we re-architected this dashboard to now provide a greater in-depth, a breadth of information, greater breadth of information on your mainframe environment specific to the PowerMax where your Z series box is connected to. For example, on the top left-hand corner, we have directors, the performance of the directors, as well as how is the hardware functioning within the PowerMax. Below it is capacity usage. In the middle, you'll see links that show performance, remote connections. So if you have a remote replication connection to another PowerMax array, you would get performance information there. And then we have the idea of mainframe objects, this concept of splits, control units, and volumes. I'm not going to dive deep right now because the next slide will go a little bit deeper in there because you need to understand that in order to to administer the box. On the far right hand side, we have an SRDF CKD relationships. And there's a source box, and then in this example, there's two target boxes. And we color code the links there between the boxes to give customers an indication how replication is performing. If the links are up, all up, they're green. If some of the links are up, then they're yellow. If none of the links are up between the boxes, it would be red. And all of these different objects within the mainframe dashboard, you can click on and sprawl out within Unisphere to get more granular information. So in order to administer the box, it's important to understand the whole concept as far as how part of the box is laid out, the PowerMax. At the very beginning, you have this split, and that split is what defines the front end ports and the associated control units. So that is where you can go in through mainframe in Unisphere 10.1 and you can create a split. You can update a split, modify a split, you can delete a split. But understand, modifying or deleting splits can negatively impact your Z host processing. And the reason why is if you take ports away from a split, then you're going to have less ports to service the I/O coming from your Z systems. Mainframe. If you were to add ports, right, that's a good thing, but you want to make sure they're balanced out accordingly. Now, for most PowerMax users, we often see one split defined in the box and then all the control units underneath. However, there are certain occasions, like some outsourcers, will have multiple splits for different entities. I've also worked with some customers that they have different business units that leverage the mainframe technology, and they might have a split for those business units. It's again, we want to give you choice, it's up to you. Then the control units, this is where you define the SSIDs and what volumes are going to be within those control units. As of today, it's 256 volumes or CKD volumes per control unit. Most customers have PAV aliases, so they may have 240 CKD volumes defined to a control unit, and then the remaining 16 is PAV aliases. Now, this is important. This is where the control units map to what's in your IOCDS on your mainframe. Then last, you have the CKD volumes. This is where you might have your mod 1, mod 3, mod 9, mod 27, mod 54, and mod A's defined in your PowerMax. So from the volumes section, you can see your CKD volumes. You can see the allocations on those CKD volumes and where they're mapped, what control units, what splits, as well as some other information within the Unisphere dashboard. Before jumping over to a demo, I wanted to just introduce Cloud IQ. If you've never seen or heard of Cloud IQ, think of it as a way to monitor your storage assets, specifically Dell storage assets, in one spot. If you have a Dell support contract, you can go to cloudiq.emc.com and log in with your Dell support credentials in order to see your storage arrays in Cloud IQ. The important thing is with PowerMax, which is what we're primarily talking about today, but also with Power Protect and other storage arrays, you need to enable the use of Cloud IQ from Unisphere. If you're interested in learning more about that, you can go search our knowledge base articles for onboarding Cloud IQ to PowerMax, or send an email to me at justin.bastin@dell.com, and I'd be happy to point you in the right direction to ensure you enable Cloud IQ successfully in Unisphere for your PowerMax environment. So now that I've talked at a high level, I'm a fan of jumping into demos. So let me navigate here over to my browser and let's jump in. So here I'm running Unisphere in embedded Unisphere, meaning it's running inside a PowerMax on my environment. So I'll go ahead and log in to my Unisphere instance with the default user ID and password. We actually document this user ID and password in the Unisphere guides. So I strongly suggest, if you haven't changed your default password, I suggest you do that when it's convenient for you. Now within Unisphere, we're going to jump here on the dashboard. And this main dashboard shows me that I have 4 PowerMax arrays connected to Unisphere. I can tell which one is the local connection, meaning where the Unisphere is running locally on the PowerMax. It's the box here ending in 949. The reason how you can tell this is by looking at it, there's a health score of 95. If I look to the box to the right of it ending in 1366 or 1646 or 1005, you can see this icon. This icon indicates it's in an SRDF relationship with the primary box over here, 949. Now, you're not going to be able to get all the performance information on the remote connected boxes, as we want to continue to primarily serve the I/O through SRDF remote replication. If you wanted to see performance metrics or more granular information on these remote boxes, if you're running embedded Unisphere on here, then get the IP address for that embedded Unisphere for these boxes. Or if you're running Unisphere in an external setup, meaning you're running it externally from PowerMax on some type of server, whether it's an x86 server or some VMware server, Hyper-V, then you could go to that server and access Unisphere and all the performance information for the PowerMax boxes. Again, I'm assuming that you've connected all those PowerMax boxes to that external server. For today, we're going to go ahead and jump in here to the local box ending in 949, and you start here on this dashboard. Now, most mainframe customers, the first place they'll want to come is in their mainframe dashboard. I do not have any SRDF CKD relationship set up, which is why it's blank here on the right hand side. Now, in order to do some management of the array, you could come in here to the split section. These are hyperlinks, and I could create a split, give it a name, give it a select path type, and then I could select the ports, directory and ports if they're available, and select run now. That's how I can create a split. If I want to, I can go through and select a split, and now I can modify it or delete it. So again, if I were to come in here, I can modify the split if I wanted to, change the name. I can deselect the director port if I want to and run now, or I can go ahead and delete the split. Again, be aware what you're doing at the split level, as it could negatively impact your Z host IO operations that are currently running. So now that I've shown you how to do splits, let's jump over to control units. So control units would map to that IOCDS file that is configured on your mainframe. So you're going to want to reach out to your ZOS systems programmer to get the information needed to properly configure the control unit section within PowerMax. If I want, I can go ahead and create a CU, and I can assign it to a split. Or if a CU exists, I can highlight, and you see information here on the right side, more detailed information of the CU, and I can come in and modify or delete the split if I wanted to. If you were to select the ... here, I believe it's an Eclipse, it gives you more information where you can do ZOS mapping operations or ZOS unmapping. This is used when you want to map a CKD volume to the control unit. And the reason why you do that is once you set up a CKD volume in Unisphere, you would want to then do a ZOS map to the control unit. When you map a CKD volume to a control unit, that is when you would go to your ZOS host operating system and format the volume using IBM's ICK DSF utility. Once you format the volume, you can vary it online and use it as you see fit. So here's the control unit section. Then if I wanted to modify or manipulate or to create volumes, I can jump down here to volumes. When I click on the hyperlink, it's going to bring me a list of all the volumes within the box. Now we limit it by 1024 volumes per panel, and you could scroll to the next screen to get the next 1024. Here's where I'm seeing the name, which is the symmetrics ID of the volume, of the UCB volume. It's not the UCB itself, it's the symmetrics ID. And then the TDEV stands for thin devices. All of this is virtually provisioned. And then the percent allocated for that volume. You can come down and see the percent allocated of the actual space taken up on the drives, on the flash drives. Here's the capacity. Here we put them in cylinders. So, mod 1 is 1,113. Mod 9 is 10,017 cylinders, and such and so forth. Down here, we have a mod 27, 32,760. There's a mod 3, 3,039. If you wanted to, you can come through and you can highlight a volume and say, for example, once you highlight it, you can expand the volume. This is using dynamic volume expansion so that you can make the volume, say, in this case, from a mod 9, and maybe I want to make it to a mod 27, giving it 32,760 cylinders. And so with that, I could expand it. Now in Unisphere, you can only do one expansion at a time. I can't select multiple volumes and do an expansion. However, Mainframe Enabler software gives you the ability to expand a range of volumes. I can expand 16 volumes, 100 volumes at a time if I wanted to. Also, it gives me the ability to create a storage group. Now, this is not a DFSMS storage group. This is a PowerMax Symmetrics storage group. And so it gives you the ability to do SLO, service level objectives, if you wanted to within PowerMax, which is only 2, Diamond and None, or it gives you additional reporting capabilities within PowerMax if you were to do SLO. You can set volumes. I'm not going to go through all these parameters, or you can do configuration of the volume. For example, if the volume was offline on your ZOS host environment, and you wanted to do a ZOSN map, this is where you would do the ZOSN map, which means take it offline from the ZOS operating system. So those are some primary administration things that mainframe customers will use with PowerMax. The other part is that I'm going to kind of end on today is performance. So coming through performance, most customers, they'll start out here. And when I say start out here, they will come up here. This is our heat map, and they will highlight the URL as I have highlighted it, and they will put that link in a standard operating procedure, in some type of document, in an email. And the reason why is if the customer starts seeing messages in ZOS syslog, they'll go and click on this heat map to see if it's something within the storage array that's not operating. So you can see here the heat map, it works by displaying various colors. Green on the left-hand side is lower utilization, 0 to 10%. And the further right you go, the hotter the color gets, where it goes all the way up to red, which is 90 to 100% utilization. So I can see I'm in a one engine box, 2 directors. Here's all my front end ports, my cache, my boards, and my disk. And I can, for example, come over here to my engine 1, director 2, EF/2D. So EF is the emulation for FICON. So you can see here it's 0%. This is a lab box and I haven't ran any test on this box. For example, so I can come down here and get utilization for various ports. So if I come down here, here's my FICON, one of my FICON front end ports, 0%. Now we default here on the last 4 hours, but maybe customers are interested in the last hour, or they're interested in the last 2 hours. Again, you have choice how you want to look at the data. And this defaults to the average, but if I select max, I start to see a little bit warmer color here on the DF emulation within the engine. Let me see if I see something within the last 6 months. Whoa, you can see that throughout the last 6 months, these are the max performance indications within the box. Again, mainframe runs awesome on this PowerMax, so we're doing very well. And then again, I can flip back to the average, which again, it looks at the average performance over the course of time. So that's one of the high areas of traffic we see that customers touch, mainframe customers touch within their environment. Another area that I strongly suggest is looking at dashboards. So within Unisphere, we provide a standard set of dashboards that you can report on. For example, in the dashboard, I can select storage groups. So this is looking at the symmetric storage groups defined on our system and gives me, for example, response time, average quality of service, host IOs a second, host throughput. Mainframe customers, what they'll do is they'll align their DFSMS storage groups, those IBM storage groups, on the z/OS host operating system. And using mainframe enablers, you can align them to a PowerMax symmetric storage group. And when you align them, we'll take the same CKD volumes that are defined in the IBM SMS storage groups, the DFSMS storage groups, and we will put them in a PowerMax symmetric storage groups, and you can get additional reporting like I'm showing here. Maybe I'm interested in the front end or the RDF directors. So if I had replication running, I can select on the RDF directors, and it will give me what the RDF directors, how they're performing, or the front end directors or port groups. So if I know what port groups that are out there, I can look to see how those are performing. Again, it's up to you what you want to report on. Here in the front end directors, you can see EF-1 docs. So these are my FICON directors. How are they performing? And this is looking over the last 6 months, but maybe I want to change it to the last 4 hours. Again, it's up to you what you want to look at. I created some custom dashboards here, and how I did that is I come over to the chart section, and I do see customers doing that. So they'll come to the chart section and they'll pick, for example, KPIs, key performance indicators. We think those are important metrics, and you can see there's 25 KPIs for this category of system. But if I select all, there's over 84 metrics. So there is a great deal of information that you can report on within your PowerMax environment. So what you can do is you can come through and you can, pick a few metrics that might be meaningful for you, and it will graph them out. And after graphing them out, say this is a meaningful chart to you, or you have multiple charts here, you can save as a dashboard. And when I save it as a dashboard, maybe it's, I'll just put meaningful, I'll just put meaning one for a meaning chart. So I'll save this as a dashboard. So now when you log into your PowerMax, if you come right to your dashboards, it will give you the ability to reference those charts that were meaningful to you. For example, now you can see there's my meaning one chart, and I'll select the meaning one chart and it will graph it. Here's FICON performance metrics. I strongly suggest 2 FICON performance metrics that you report on. It's the FICON port threads and the percent idle, FICON port threads percent busy, as well as FICON emulation threads percent busy. Those metrics really can give us and you a good indication how the FICON emulation is performing within your PowerMax environment. But again, I created those charts and then I saved them so that now if I want to come see an immediate possible performance issue with the PowerMax, is the storage causing the application issue, then I can come here and look at it. So those are 2 areas, the dashboards, the charts, creating charts that are meaningful to you and save them as dashboards that customers really leverage within the Unisphere environment. And then I would say the one thing is the plan report. So within the plan report, I view this as your capacity planner, our capacity planner. So SRP stands for Storage Resource Pool, and I can select an SRP. And although I haven't really been writing much to this box, here maybe after 3 to 6 months after you've loaded your PowerMax, you might want to come out here and look at percent use capacity projection. So the blue line, if I did anything, would give me the actual used capacity on this box. The yellow line gives me the used capacity projection. It defaults to a week. So I look at today's date of April 2nd and go out a week, and that's what the capacity that will be used a week from now. But customers will run this on a month, so it goes out 30 days, 3 months, and 6 months from now. So it gives you an indication if you're going to run out of capacity within 6 months or 3 months or 1 month or 1 week from now. And I'll have customers come in and schedule this as a report so they can run this report once a week and get it sent to them. And so they can send this report to them if you set up the notifications in Unisphere. And again, I'm more than happy to show you how to do that. You do it in the settings area up here under alerts, alert notifications. If you set up the emails that you want to send reports to, that is how you can get this report sent out from Unisphere to interested parties or the stakeholders that need to know this information. Also, if you want, we have a report section here under performance where we will save the report by default for 7 days. After 7 days, you can see I ran some reports. It would then keep it on there until someone goes in and deletes the report from Unisphere. So in my part of the presentation, I showed you Unisphere, I showed you splits, modifying, creating splits, control units, CKD volumes if you wanted to. I went through and showed you performance, managing some performance, looking at some of the most important performance metrics, the FICON emulation threads, the FICON port threads, looking at those metrics and setting it up. Also showed you the heat map, the capacity projection tool within Unisphere, really just to manage it. So once you set your mainframe, kind of config and forget it, the continuous upkeep, setting those reports up so that you don't always have to log in unless you need to. The other part that I was going to mention is Cloud IQ. Again, if you set up Cloud IQ, which is done through Unisphere on your PowerMax to leverage Cloud IQ, then you can come in here and you can start monitoring your storage environments from Cloud IQ. One important note is that you cannot do what I call CRUD operations from Cloud IQ, which is CRUD is create, replace, update, and delete. You can only do that from either mainframe enabler, from Unisphere, from solutions enabler, which is the command line interface, or REST APIs. You cannot do it from Cloud IQ. So it's a really good way for operators or people newer to the mainframe platform to come and get information from their environment rather than, for example, you come in and give them Unisphere right away where they have that ability. So I'm not going to drill in deep here into Cloud IQ. Maybe I can do this for another session in the future. So with that said, I'm going to end it here and I'm going to turn it over to my colleague and dear friend Paul Martin to dive deeper into the PowerMax REST API and how you can use it to do configuration, administration, but also get performance metrics from it. Okay, thank you so much for your time and I'll talk to you soon. Bye-bye.
Thank you, Justin, for a great overview of the user interfaces for mainframe. I'm Paul Martin, Senior Principal Engineer at Dell, and I'm going to take you through some of the automation capabilities of PowerMax with our REST API. For anyone who's not already familiar with REST API, REST is a framework for automation. It stands for Representational State Transfer. It's based on the HTTP protocol, so if you can understand the addresses that you see every day in your web browser, you can understand REST. REST is popular with its wide adoption by all sorts of tools and basically every programming language out there. And the internet is chock full of examples to get you started and get you productive quickly. Most modern infrastructure tools, including every Dell product and array, provides a REST API interface, making it easier than ever to combine capabilities and create automation workflows that would have been impossible with legacy tools. The REST API for PowerMax is provided by the Unisphere for PowerMax application. Whether that's internal, running on the array, or installed on a separate server, the functionality is exactly the same. All of the calls use HTTPS, so they're secure, protected with TLS encryption. Every call that's made into the array is authenticated using username and password, and a role is checked to make sure that that user has permission on the objects that they're trying to create or to perform the actions that they're trying to perform on the array. The API is organized by version and resource for simple navigation, providing the create, read, update, and delete functions in form of post, get, put, and delete through the REST API methods. There's simplified scripting workflows compared to CLI with the REST API. The single API call can provide the functionality of many API calls, making it relatively easy to do complicated things quickly just by filling in a few key value pairs. And we'll see that in the demo in just a second. Moving swiftly along, let's have a look at the demo portion of this session. I just wanted to give you guys a quick overview of where to get more information on the API. So we have this developer.dell.com site where you can get information on any of our APIs, as well as some interesting articles from time to time, some training videos. But just want to click on the Explore APIs and just do a quick search for the PowerMax API. So this will bring up the documentation that gives you a lot more information about the API, the various different API calls that we can use, as well as all of the different options that are available for you when you're building up more complex calls, or if you're not sure what a return is going to be, you can see what the return would look like. So here we get an introduction. Let's see, there's two different types of endpoints. There's regular endpoints and enhanced endpoints. We're going to look at both of them. You just see there's a slight difference in the address. One has a /REST API and the other one is /REST v1. So the enhanced endpoints we will look at in this API. And here we have all the different resources organized. So here are the mainframe ones. So these are all of the mainframe calls, and we're going to cover the majority of these within the presentation. So if you're wanted to see where I got the information, I would have taken it from this documentation. As well as this, I'm going to use a tool called Postman. So Postman is it's a developer tool used for making API calls. You can make API calls, you can test API calls, and you can also generate code, which is very useful, especially if you just want to knock up a quick script to get information quickly in Python or Ruby or PowerShell or whatever, even just curl if you're just running it from one of your Z-Linux machines and you just want to execute a curl command to get some information from the Unisphere system. You can do that through here. For the demo, I've taken a selection of calls, I've organized them in folders with various different calls, and I've set up some variables. So I've set up my Unisphere IP, I've also set up the array that I'm going to be working with, as well as some other things. I've set up my authorization, as we mentioned in the overview. Every API call is going to be checked with the username and password. I'm using a system admin level username, so I've got the highest privileges, so I can run absolutely anything. For the first call we're going to run, I'm just going to connect to the Unisphere system, run a get call. So a get call, as I explained earlier, is to get information from the array. We're not changing anything, we're just finding out information from the API. So here I'm going into the mainframe resource. I'm on version 101 of the API, which is 10.1, and I'm making a call to this metrics sub-resource on the mainframe. So if I click on this, this executes the call, sends the request to Unisphere, and I get a response back here. So what we see in the response is a JSON payload, so in between the curly brackets. I get one key back with a list of arrays that are capable of mainframe operations. So array 949 and 1005. So both of these systems are connected to this Unisphere system. If I want to see what that would look like in code, here's a little code snippet. By clicking on the code snippet tool, I can see what it looks like in Python. I can see what it looks like in PHP with curl if I want to embed that into a web page. Or I can choose any of the other various different tools, even just a native curl command, which is a tool for making REST calls as well. If I wanted to tell the array to do something, or tell the Unisphere system to do something, I can make what's called a post call. So the post call generally has some inputs. So in the body of this call, I am telling it I need to specify some parameters. This one's really simple, which is why I've chosen it to run the system health check. I just need to supply a description of the health check. So if I run that call, it tells the system, go off, execute a health check, and I'll come back later and check on that. So here I get my response. It's executed a job on the system. It's got a name mainframe, and it's going to be it's going to execute when it does. Whenever that has executed, what I can do is I can go to make a get call to the health check, and I can get a list of health checks that have been run on the system already. So here I see I've got a health check ending in 4627. So this is the health check ID that's been returned. And I can then go one level deeper and check those results. So if I put that health check ID onto the end of my API call, so under the same resource, but this time instead I'm using a get instead of a post, and click send. So here I'm getting back the health of the array. So this is the same information that's in the health check that's on the mainframe dashboard that Justin showed you. So I can see that it runs various tests, like what the vault state on the array is like, what my spare drives are like, what the memory tests are like. If I see true, it means that the test is run successfully. If I see false, the test has failed for some reason. We may need to investigate further. But that's a brief introduction into running a few simple REST calls. Now we're going to look at some of the enhanced calls in just a second. Okay, so we've looked at how we can get some basic information from the REST API about the system, about the health, and just looked at some of the basic level calls. One of the main use cases that people tend to have when they're working with our API is to get performance data for their array and its components. A lot of customers tend to take this information and put it into time series databases or even tools that they built themselves. So the performance API and the latest API has been enhanced to make it easier than ever to get information about the array. All of the calls in the enhanced API are get calls, as you see here. You see the little get in green, telling us that that's the method that we're going to use. So we don't have to supply any additional parameters. We just supply the URL for the call that we want to execute. So in order to find out what they are, I can query the array for the performance categories. So using this call, I'm going out to unitymax/rest/v1 /systems and identified by the array ID and /performance categories. I get the list back of the performance categories that are available for my array. Now this will these performance categories will change depending on the array model, which is handy. You don't have to do anything fancy in your code. The API knows what's available for that array model, and it tells you back the categories identified by their ID. It also tells you what metrics are going to be returned. So you don't necessarily need to look up the documentation. All you really need is this endpoint, which we can then change and append onto depending on the on the category we're interested in. So I might be interested in getting information on the front end ports and how they're performing. So if I issue the get call for the front end ports, I get back a list of metric instances for each of the front end ports on the system, as well as the metrics for those ports for the last 5 minutes of diagnostic data. So here I've got back the response times, read and write, and overall response times, number of IOs, the megabits per second broken down by read and write, the IO size, and the speed of the port, as well as the most important thing, which is the timestamp for the metrics. So this timestamp here is an epoch time, so that's the Unix timestamp. We need to do a conversion to make that human readable. Anytime series database will take care of that for you, or you can just use API libraries in your programming language to work with it. Another category that might be of interest, especially to our mainframe customers like yourselves, is the Ficon emulation thread. So if I run that, you just notice that all I'm changing as I'm running these API calls is just changing the address and swapping out the category on the end. So here I get back the metric instances, again identified by ID, and we have our metrics key. So we're getting back the percentage busy and this percentage idle time and the timestamp for those metrics. I may also be interested in the Ficon port thread data. So I can query that. Again, getting back that information. So similar to before, just getting different instances and timestamps. Now, numbers on mine are very low. I'd expect your system to run a little bit, actually doing more work. And you can query other metrics as well. So if you're running remote replication, you might be interested in SRDF performance categories. I don't actually have any replication running on my array at the moment, so this request will actually just time out. The same for the SRDFA, but those are available to you. And if we look at the performance categories, we would see under here, if I just do a little search for SRDF. So just looking for the yeah, RDFS, sorry, I searched for the wrong thing. So under the RDFS, if I do query that performance category, I'm going to get back all of these metrics. So not very much guesswork, but pretty easy. And we will enhance this over time to give you more data back. The initial response for this is only giving back the latest 5 minutes of performance data. But if you're gathering that on a regular cadence, you will have the performance data going back further on a regular basis. If you do need to query, greater than the last 5 minutes, which may be the case, we have the full performance API, which would require you to build up a post call, and information on that's available on the documentation as well. So hopefully that was useful. And we'll have a look now at how to provision storage and gather configuration information with the REST API.
So just before we wrap up,
we'll enhance this over time to give. Sorry, guys. Looks like I cut the video short, which gives us an opportunity here to do some live demo. The video edit seems to have cut off the performance piece. So I'm just going to spin up the same Postman client here and show the calls that we were just running. I would put into the chat that the I did put into the chat that the Postman collection that I'm showing is available. Sorry, 1 second. That Google. Nothing like a live demo. Sorry, Brett, can you just confirm that you can see my screen?
Yes,
Okay, perfect.
we've just got a timer going at the moment.
Okay, no worries. So we've about 10 minutes, I'm guessing.
Yeah,
Okay.
here we go.
Okay, so what the video didn't show was the provisioning API calls. So if I want to, so Justin showed through the UI how you can get how you can go through the mainframe splits and all of that through the UI. All of the information through the UI is available through the REST API. Using get calls to find out information, post calls to create new objects, and put calls to modify existing objects, and delete calls to make some changes. So if I make a call out to the get call to the API, I'm going here through the base address to the Unisphere system, which is the IP address of the Unisphere host /univmax/REST API, into the mainframe resource, and identifying the array and specifying split, which is the resource we're interested in. A HTTP call is made out to the array, and I get back the list of splits that are on the system. So this is the same split that Justin looked at in Unisphere. And here I see that there are two splits on the system, split 0 and split 2. Now, the way the API works is it's a natural progression. So when you want to dive a bit deeper, if I wanted to get information on split 0 and what's configured on split 0, I would simply expand the endpoint and append that on. So if I go into the next call, split details or get split details, the address has just changed with the split 0 appended on here, and I click on send, I get the information back. So here I can see that the name of the split is split 0. The PAV type is hyper PAV. I can see what the alpha serial number is from the mainframe, so that's very important, and the CU image number, as well as what associated ports it's using. So on the array, this split is presenting volumes out port EF1D port 2. So that's where the volumes will be made visible. We can also go, if you wanted to create a new split on the system. So Justin showed that in the UI. What happens is we use a post call. So post call is basically a description of you send a request to the system with a description of what you want to create. So that's where you're looking up the documentation. So you look up the documentation to see what are the required parameters and what values you need to give them. So you need to provide some basic information. So I could create a split called my new split, give it a PAV type, and tell it what ports to associate it. So the square brackets here indicate a list, and you see that I'm presenting a couple of ports to associate. Now, if I click send to execute that, that would create a new one on the system. I don't want to actually execute that because it is a live system, and we have people testing there, so I don't want to upset what people are testing. If I wanted to modify an existing object like a split, what I can do is I can do what's called a put call. So put is a modify. This also requires a body. So the body is in JSON, just like before. So JSON is the JavaScript object notation. And I can, again, the payload is documented in the developer.dell.com documentation space. And what I can do there is I can do things like rename the split, change the PAV type, or give it a new name. In this case, if I executed this one, it would rename split 0 because that's where the the API call is being directed to a new split name that I've specified in here. And likewise, there's another call for the documentation, which is to delete. So if I wanted to delete, and you can see here that I've appended a split ID to be deleted, which doesn't actually exist on my system because I don't want to delete anything. And the delete will have some guardrails around it on the symmetric, so you won't be able to delete the split that has CU images attached or volumes in the CU images. So we do have some guardrails around there. There's the same information is the same information and operations are available for the CU images. So if I want to see what CU images are on split 0, again, I run a get call /CU images, and that will give me the CU images that are available. So here I see that there's one CU image with the identifier 0x002. If I want to find out what's on that CU image, I've just changed the address in the next get call, and I can find out that this CU image, it's online, it has 23 volumes, there's 3 storage groups associated with that, and I can see what base addresses are in use. So all useful information to help you automate some of the mainframe information gathering, or even the creation. We have some customers that are using these REST API calls with tools like Ansible to automate some of their operations. Actually, so I've actually just created a new CU image ID there. So this was the option to create a new CU image. So I created a CU image with 058 with this SSID and using these base addresses. So this is the body that's available there. Again, there's the modify options for CU images. So there's a number of different things you can change, and the delete operations. When you're provisioning mainframe volumes as well, that's also supported through the UI. So the adds, moves, and changes for the volumes are there. So this is a little bit of a bigger payload. So whenever we're creating a volume on the mainframe, we need to tell it, what base address we're going to use, how many volumes, what storage group we're going to provision the volume in, the emulation that you're using, so your CKD 3390s or whatever type of emulation your mainframe is using, whether or not you want to have compression on the volumes. So with the latest PowerMax arrays, we support data reduction on mainframe volumes. And if you want to set a workload, and you can create multiple volumes at the same time. You can even specify identifiers if there's additional parameters. I've just picked out the base example here just to show you a very simple REST API call. Now, there is a lot more information available to you guys on the APIs. I run a regular, I write some regular blogs as well as Justin. So up on the InfoHub site on Dell Technologies, so infohub.delltechnologies.com, there's a number of different blog posts there on various different topics. I'm generally blogging on the REST APIs and integration with ITSM tools and interesting things that customers have come to us with and want more information with, and just putting it out there to the public. We have that developer.dell.com site where you've got information on all of the APIs, so your mainframe APIs, and as well as other APIs, like we've got remote replication snapshots and stuff like that available. I've put the collection available to you on GitHub, so that collection that I've just shown you through Postman. You can download this file and implement or import it into Postman. Just change the variables to match your system. I would recommend just running get calls because they're safe, unless you want to run a post call yourself if you're sure you actually want to create something. And for Unisphere as well, if you go to support dell.com/support, there are a number of different resources available there. So the Unisphere for PowerMax online help, and the guides are useful if there's if there's things you want to investigate as well. So the product guides are there. And if you're interested in Python as a programming language, we do supply a Python SDK. I'm the lead developer on this tool. We have support for mainframe provisioning, as well as the the full REST API. So if you want to just write Python scripts without having to look up the different API call, all of the documentation, this site is this SDK is available. It's fully documented as well, with its own documentation on read the docs with a programmer's guide on how to get started. So we do provide a lot of resources there for our customers. And I've seen Roy has a question there on the REST API. Can you run can you run it from the mainframe itself? You can run REST API calls, Roy, from the mainframe. The way I would be familiar with that, now I'm not a mainframe expert, but from the ZOS side, if you're running Z Linux, you can run curl commands from Z Linux, and those calls can be executed. If you look in Postman and click on this little code icon here, that code icon gives you the curl command. So basically it's a curl command. You tell it what location. So that's the address that you're going to. We need to specify some headers, which is your authentication, and this is the encoded password in base64. And if you're running a post call, it'll have the data. So I can follow up with some examples. I'll put my email into the chat here as well. If you want to shoot me an email direct, I can follow up on that. But definitely, that is something you can do. So guys, I'm sorry about the little snafu on the video. I think I just played the wrong recording. So apologies for that. I hope this was interesting to everybody, and thank you for taking time out of your day to listen to myself and Justin. So
thank you, Paul. For those of us of a certain age, we'll remember a television program on BBC One called Tomorrow's World, where they did live scientific experiments. And of course, the live ones never worked.
Well, it's we were kind of the opposite, Brett. It was the my recording worked. Obviously, I never watched it the whole way through because I can't stand listening to my voice. So
yeah. So many thanks, Paul, and I'll ping an email to Justin as well. I really enjoyed that video, so thank you both for this presentation.
Thanks.
Okay, it's 10 o'clock, so enjoy the rest of the day, everybody, and maybe see you later in a future storage stream video. Thank you, Paul.